I'm with the OpenBSD project, and my talk is using BGP to distribute real-time import and export. Is this better?
Yeah.
Yes, okay. Using BGP to do real-time distribution of the import and export of OpenBSD SPAMD entries. Please forgive me for my voice. I'm feeling a little under the weather. It's been really raspy. So I will give you some definitions first. So SPAMD uses IP host entries to whitelist, blacklist, or greylist hosts. It's a network-based spam mechanism, or anti-spam mechanism. It does not do any sort of content measurement or content reading. So SPAMD can import and export these lists. Now, piece of trivia, IP host entries can trivially be expressed as a route. And in IPv4, they would be what's known as a /32 route, and IPv6 a /128 route. BGP is used to distribute these IP route lists. So what we can do is we can tie the two mechanisms together to distribute these lists. So, give you a little history. SPAMD, written primarily by Bob Beck of OpenBSD. It's been included in OpenBSD since version 3.3, so about 10 years ago now. The Greylisting support was entered in OpenBSD 3.5. Greylisting basically forces unknown senders to retry delivery. The default configuration, when a unknown server sends SPAMD mail, SPAMD will capture this and return back a temporary failure code, error 451 specifically. And so the sender will have to try to send it again. This is extremely effective against bot networks that send spam. What a lot of them do is they simply just they do one simple connection attempt, and if that succeeds, then it's delivered. If it has failed, they don't send you any more mail and just go to the next person. However, nearly all legitimate email servers that exist do queue the email and attempt to redeliver. I think there's a small number of companies, probably like 3 or 4 in the whole world, where their mail server does not do correct retransmission attempts. SPAMD also is capable of using blacklists to reject mail from known bad senders. These are senders that have either attacked your lists or have attacked other people's systems. So SPAMD has a mechanism to fetch blacklists from other systems, from a central server. This is traditionally configured with the SPAMD setup program, which runs at the top of the hour, every hour, and fetches it from a single web server. Most common in the default OpenBSD configuration, it is a 2-line change to enable fetching from the central OpenBSD web server. And so, as you can imagine, at 12:58, there's not a lot of traffic. 12:59 is not a lot of traffic. At 1 o'clock, everyone in the world hits it, and the downloads take quite a while. And then at 1:01, not much traffic. So then BGP. BGP is probably the most critical piece of technology that exists on the internet today. It is used to distribute the approximately 400,000 plus routes in what's known as the global routing table. This is how every network knows how to talk to everyone else. It scales incredibly high, it scales incredibly fast.
Tell that to a Cisco admin.
Yes, so this scales incredibly high, incredibly fast, as long as you have a machine with more than 3 megahertz of CPU. Traditionally, Cisco routers don't...
More than $3 of CPU.
True, more than $3 CPU as well.
What do you expect? When you spend €1 million on a device, you get a $5 CPU? That's fair, isn't it?
That is very fair. Traditionally, people like to say that their mobile phone has more computing power than went to the moon.
That's true.
But my calculator has more power than a Cisco router does. And so there's a very minor feature in BGP that we'll be exploiting to do this called communities. The BGP communities allow you to mark a route with an optional site-specific attribute. This is just an arbitrary string. Here is an example of a community. And so you can just attach it to a route and distribute it, and the receiving peer will receive this and can make whatever decision they want based on this information. There is a standard for the format. There is not a standard for any meaning of this. It can commonly be used to do, like, say, this network is attacking me, black hole it, or this is a lower priority than other networks, so do other various BGP tricks to this. This is the secret sauce. This is the core of this idea. That's where everything depends on. So the software we're using to do this is OpenBGPD, written by Henning Bauer, who's heckling me in the audience, and Claudio Yecker. Yeah. It's been included in OpenBSD since about version 3.5. It's software-based, so we can use the power of a general-purpose OS, like scripting or cron, or having a CPU that costs more than $3. So, interestingly, everything that we're using, except for our own custom shell scripts, are built in directly to BGP and SPAMD. With one thing, which is I fixed a table length, the PF table name length. And that will be in the upcoming OpenBSD 5.3 release. But that is not mandatory for running this. You can just use a shorter table name. I wanted the longer ones to be a little bit more descriptive. That was it. Also, interestingly, when looking through the history of this, in about 2006, one of our developers added a feature which I depend on, and in the commit message mentioned this can be used to export IP address lists such as SPAMD.
We thought about that, yes.
Yes, it's been thought about for a long time, and I had no knowledge of this when I reinvented this whole thing. It was like internal discussions. So how do we tie these together? First, we need to export the IP address lists, and then we need to import them together. So the exporting the IP address list happens on what I'm calling the SPAMD source systems. These are the source of information providing data to SPAMD. So what we do is we only list specific IP addresses that exhibit specific behavior. Either it passes what we define for whitelisting, or it passes what we define for blacklisting. We will not ever penalize a network neighbor. This is traditional behavior from other anti-spam IP address lists, and this penalizes a huge amount of people in a very unfair way. And so, I'm quite against this. Yes, we just want this to be simplistic. We want to catch the low-hanging fruit. We want it to be the first line of defense. It's not going to be the full capable solution for anti-spam, but we want to catch the easy to identify things, so you can dedicate your $3 CPU to cycles of scanning the actual contents of the message, if for Viagra or whatever, and handle this. So first we have to select known good sources, because if you have bad sources, then the data is basically useless. We want to be conservative, as conservative as possible. I would much rather an address not be listed in either the white or the black lists than to falsely mark one as white or black. Greylisting is still very powerful, but it can only be powerful when it's being available and when it's being used. If a system is on the white or black list and and your system is configured to utilize this, then you skip the entire greylisting process. So where do we get the blacklists? The blacklists sent a mail to a spam trap address. That's the only way that we're accepting it right now. Once you send a mail to a spam trap address, if you're not familiar with this, is an email address that is published on a website hidden in a way where humans cannot find it, but bots can. And when a bot sends an email to this, it has never been announced before. It's only in one place. And so this is obviously a illegitimate email. So what happens is that when we receive this, for the next 24 hours, we will mark this as a blacklisted source. And after 24 hours, then that IP address falls off the list until it sends another email. So again, we want to be conservative and do not be overly aggressive. So once we receive the information on one of the sources, we literally run this command here. So this command simply tells the BGP to use the network mechanism or network subsystem to add this IP address, so hostname, and then mark it with community. The 65066, the front part of it, is our local AS. This is from the private AS range, which is roughly the 19 to 18 equivalent. And then we use the marker of 666 to declare it as evil. So the whitelists are quite similar. We're calling them semi-trusted. Basically what happens is that within 75 days, so we've known about them for more than 75 days, and they have sent us more than 10 emails. We figure that within this time frame, an email server admin would have been able to identify if they are a spam source or if it's a legitimate email. So we do not want to be overly aggressive and list too many addresses in this whitelist. And so, again, we have basically the same thing. That's just the appropriate IP address, and then we just change the community, and this time we just use 42 for semi-trusted. These were just arbitrary numbers. It can be anything you want. That's just the ones I'm using for these papers. So then the SPAMD sources connect to our route server. The route server is the center of the universe. Everything talks to it. It is basically set up in a star topology where you have you have all of your SPAMD sources. Right now we have 3 that are connecting to a central machine. This machine is receiving them, scanning the information for various pieces of validity, and sending them to all the peers. So we only accept addresses from the SPAMD source systems. We do not allow the peers, or rather the client systems, to inject any information into this network. We also only accept host routes. We want to make sure that a sending server cannot accidentally blacklist or whitelist entire subnets. If they want to do it by hand. You want to be conservative and make this type of behavior difficult to do. We then also mark them we keep the original AS number for the various upstream, for our various SPAMD source systems, but we also mark them with our AS 42 or 666. This gives the end user the possibility of being able to say, I trust 2 of your upstream servers, but I don't like the information I've gotten from a 3rd one. So I will split out the information and only use 2. You could also do interesting tricks on the blacklist side, which I'll show you later. So then we get to the clients. The clients clearly receive the black and white list. It separates it out and applies the local configuration. The whitelist entries are added to a PF table. This allows them to simply bypass SPAMD, and you will be receiving emails faster. It's as if they've already cleared your whitelisting. This solves a problem when you receive an email from a server that you don't know before, that it will be delayed by approximately 30 minutes before the first email is actually delivered. If this email server has sent any one of our upstream services, the emails have gotten added to their whitelist, then we will know that information as well. So a smaller email server will gain the power and the knowledge that these larger servers do have. So here is some of the meat for the client-side whitelist. So we're going to add this table entry here, BGP SPAMD bypass. And then we have the normal configuration, and we also pass in from this to the SMTP transaction. That allows us to bypass SPAMD. And the rest of it is the normal SPAMD configuration within PF. So we get to the blacklists. Well, we could block the connections from these machines in PF, but that can be dangerous. So what usually happens is somebody very important at your company, usually for a company like your CEO, they're waiting to receive an email from somebody for a business deal. Now, one of their marketing people did something a little questionable and bought this list of IP, or bought a list of email addresses to send the marketing materials to, and so they added one of your spam trap addresses to this, and now they're being blacklisted. What do you do? So we don't want to block this in PF, because then they will just think your email is down. So instead you want to actually tell them they're being blacklisted, so their admin can do something about it, or your admin can do something about it. So, as a warning, this is a work in progress. It is a little bit ugly, and we fully intend to improve on this, but the work has not been done yet. So this is two mechanisms. So this is the AS of the system that we want to monitor from. So this is the 65066 is the AS that we're using for our route server. And basically, we pull the blacklist and then just put just the IP addresses into a file and then run SPAMD setup. SPAMD setup will take the information of this file, and I'll show that here. And so it tells you that it adds it as a blacklist, and then gives a reply message, your address, and then the %A is expanded to the IP address. And it pulls it in from spamd.black. So this way, when an email server on the blacklist sends you a mail, they receive this information in their logs, and then they can attempt to discuss this with your mail server admin about either maybe getting off this list or whatever needs to be done. So there are a number of security concerns with this, mostly due with the data coming over the network. So where do we get the IP addresses from? Currently we have 3 upstream sources. We're getting the blacklist and whitelist from the University of Alberta, which is the same default blacklist that is available in OpenBSD. We are also getting data from Bob Beck from obtuse.com, who also runs a fairly good-sized mail server. We are also getting data from Peter Hanstein, who is the author of Book of PF and other OpenBSD-related documentation. And eventually, once Henning, stops having a broken shoulder, he will come in and feed me his information as well.
Want mine?
Are you big enough?
I have 2 email addresses.
Excellent. Well, we can talk outside of this about getting other servers. I'm not super interested in having too many, but I want to have a number of pieces of data. So we receive the IP addresses from known trusted sources. Right now, these are people that I personally know and I personally trust.
Okay, sorry.
So right out.
If you show me your list and you tell me what your selection criteria is, we can discuss it. What is the criteria for adding IP address to the blacklist or whitelists? Right now, we want to be as conservative as possible. We want to avoid manual entries in the network. We want to avoid any sort of retaliations for people for other things. We want to avoid non-email attacks. For example, if a site sends a DDoS to the system, I really don't want this added to the blacklist. It doesn't, just because it says a DDoS doesn't mean they're just going to send spam. Besides, if they're not known on the blacklist or whitelists, they will have to deal with greylisting anyways. How do we prevent just random people from inserting information? What this does is in the configuration that are used. One, the client machines do not send any data to me, and two, I reject any data I receive. The only data that I receive and process come from these trusted sources. Some people have been asking me, how does this tie in with the global routing table? This is BGP, isn't it? Well, it is, but the BGP global routing table is a completely separate instance. That is simply those BGP routers talking to each other. It just so happens there's like 5,000 BGP routers, 10,000, whatever. There's a huge number of them. Ours are just simply not part of this. It is a separate implementation. Wait a minute, this is BGP. Am I going to be adjusting my routes on this? Am I going to be changing my route? Like, my routes will be pointing to somewhere random and I can't actually connect to these. No. There is a feature built into BGP that very happily just completely turns off the routes. Adding any learned routes into the routing table for your machine. We're simply using BGP as a distribution mechanism. We're decoupling, decoupling the FIB.
Well, decouple is the term. So.
Decouple, okay. So, this sounds interesting. I want to use it. The problem is...
You want to?
I do want to use it. It'd be great and wonderful. But like, do I have all these routes? Well, I am now running a reference server for this. It's available today, available at bgp-spamd.net. I am running this for basically the entirety of the year, and very hopefully I'll come back next year and discuss the lessons learned and various pieces of statistics about this. All configurations and scripts will be available. This will be fully BSD licensed, available for anyone to use. However, be aware, maybe at the end of the year I decide to shut it down. There will be there's a mailing list available where I will do important announcements, including any possible shutdown notifications. As of approximately 1 hour ago, there were 48,457 entries in the blacklist and 124,000 entries in the whitelist. The whitelist stays pretty stable because that is not time-based. That is, once you cross a threshold, you're in. The blacklist entry kind of ranges depending on the time of day and which day it is, and is it a holiday in the United States. Anywhere from the lowest I remember seeing is about 30,000, the highest has been 90,000.
So of those two lists, only the whitelist entries end up in your PF table, right?
So the question is, out of these two lists, which one ends up in the PF table? And yes, correct. Right now, only the whitelist entries get added to the PF table to skip being processed by SPAMD. The blacklist entries is saved to the file and handled by SPAMD itself.
And that number is a big number, but it doesn't cause any problems for PF.
It does not cause any problems for PF. It does use a little bit of memory. I believe it's 5 megs of kernel memory.
Something like that, yeah.
Yeah.
The tails are very, very memory efficient on purpose. We've tried them with millions of entries, so that's basically nothing.
Yeah, it's basically
performance is fast.
Performance is very fast, yes. Essentially, if you're running this on a 16 megabyte router, like you have your fancy little Cisco, then you will run into memory issues there. But if you have a machine with more than $3 worth of RAM, there will be no problem.
If you run this on a Cisco or a VEX, you're an idiot.
If you run it on Cisco or VEX, I want to talk to you because I want to find out how you did it. And I'm very curious to look to investigate this. Yes. Okay, so yeah, there's future work. We already want to accelerate adding the addresses to the BGP feed. Currently, we're using cron to do this, which is suboptimal. We want to do a much tighter coupling between BGP and SPAMD so they can talk to each other directly and be able to pass the lists on in as near real time as possible. We also want to do network aggregation if this is feasible. The problem with, so we can drop the list down. We're sending 200,000 routes around the machines, and this simply takes time to send over the network. So we want to do aggregation, and if we have 256 entries consecutively, we want to send to /24 instead of /32. But that creates some problems, because you have, each of these are marked with very specific communities, and the communities are critical to the knowledge of, is it a blacklist or a whitelist? You also have problems of what happens if you have a blacklist of /24, and then one machine in the middle times out, then you have to deaggregate, reaggregate, and send all the information around. That can be difficult, but this is, we want to experiment with this and see what the performance hit is. Excuse me, and is it reasonable? How many times does this happen? This is a semi-experimental network. However, it all fully works as is today. But we would like to improve it and experiment and see what more information we can get. Okay, so I'd like to give acknowledgements. Bob Beck is the co-author on the paper that we wrote and submitted to your proceedings. I would like to give him a lot of thanks. I'd like to give a lot of thanks to Peter Hanstein, Bob Beck, and University of Alberta for feeding me this data and for working with me carefully. I also received a generous donation of hosting for this project from Sonic.net and ISP in California. And I'm very, very grateful to them for this. So, are there any questions?
It's not a question specifically about the BGP implementation, but I'm curious to know in general, how do we deal with SPAMD with hosts that don't easily pass the graylisting process because they keep sending mails from different IP addresses each time they retry?
Okay, so the question is how does SPAMD deal with, let's just call it the Gmail problem, where you have a network of hosts attempting redeliveries over a network instead of specific IP addresses?
The answer is easy, it doesn't.
The answer is easy, it doesn't. However, this mechanism...
This allows it because you can put it in the whitelist, right?
Exactly, because this allows it because over time, for example, the Google mail servers all eventually pass the whitelist because they send you enough information.
So I guess my question is, how do they get it in the whitelist in the first place? I mean, you have to at some point manually add them, I guess.
Kind of. So yeah. So how do we get these into the whitelist in the first place? There are three basic ways.
There's one easy solution to that, which is the one I applied. It's called volume. If your mail installation is big enough, the Gmail service will send stuff so often that they're pretty...
Well, mine isn't, right? I have 2 users somewhere.
Right, exactly.
I never whitelisted a single Gmail host, but they are all whitelisted just by the volume they send.
Well, let me just finish up. Yeah, so as Henning was saying, that the answer is basically volume. Another answer is some people simply manually whitelist them as they see them in the whitelist. And also, Google does publish the net blocks they use via the SPF. And you can pull this information and add it to your whitelist manually.
If you know about
it. That's the only use case for SPF. You can
you can
grab the email senders from the SPF record.
Yes, that is a wonderful.
It's not just Google. There are many of them.
Yes, many of these large networks.
Is Yahoo doing it now? Because they didn't, and with Yahoo it was immersive.
I'm pretty sure they do now. But yes, but as I said, you are utilizing the knowledge that these larger networks have, who receive the massive volume and who whitelist Google, and then that'll be added into your local.
So, I mean, I can solve this problem for myself by using your whitelist.
Yes, exactly. Yeah. So the comment was he can solve the problem for himself simply by using the whitelist. Yes, you're utilizing the power of these large installations when you are a small user, and this also solves the distribution problem because. Again, you have, when you're posting on a website, you have to deal with this, and you wonder about the load, and oh my god, everybody pulls it once an hour. And so the file server, the web server gets a lot of traffic, a lot of data. But using BGP, then once they add it to the network, it gets sent to my reference server, and then that is distributed live to all the customers. Scale is very large. This is used for the backbone of the internet. And updating your routes in a real-time fashion is extremely critical. So the BGP developers have focused on solving this problem. please.
What could be possible program in your strategy? I mean, distributing IP address list via BGP if IPv6 is fully deployed everywhere.
Okay, so the question is what could be the problems with this mechanism if IPv6 is actually fully deployed and is being used for mail service? Henning is showing his laptop, but I will not copy those comments. So essentially, this is roughly the same problem. It just grows a lot in scale. That we have to send around a lot of IP addresses. At that point, thankfully, people are not using the entirety of their V6 networks. I believe the official way of numbering is to do the MAC address dance, which is still a single IP address for a single machine. I'm not sure. Well, again, that's something that we need to investigate and look at for scalability problems. Now, BGP does handle IPv6. BGP is being used on the backends for V6. So the BGP people are already dealing with this problem. And essentially, I will just follow what they do. And since we have more than a $3 CPU, and we're not super interested in routing millions of packets to these machines. We're simply interested in processing emails. We can handle more load than some of these dedicated routers because those are all focused on a different subject. Additionally, this can be network-based. You can offload this onto a machine in the middle of the network as opposed to one in the core or directly on the mail server. I am personally running on my mail server right now because I just don't feel like setting up another box for it. It is not, the load is not noticeable. The reference server right now is, I believe it's a 1.6 gigahertz Celeron. Not super powerful, but it doesn't notice anything. And I can download the full 200,000 IP address list over my home DSL modem in approximately 7 seconds. And that's just mostly that is just simply pulling the IP address, it's just bandwidth. So, any other questions?
So we have OpenBGPD and OpenSMT and SPAMD in FreeBSD ports. Is there any reason why this could be implemented on something other than BSD?
Okay, so the question basically is portability. FreeBSD has OpenBGPD and SPAMD in ports. Can this be implemented on other OSs? The answer is yes. So BGPD is simply being used as a transmission mechanism. As long as your BGP solution can receive these and then export these lists based on communities to a program or a file or anything, you can simply load them however you want and wherever you want. Everything that I am supplying will be focused on OpenBSD and using these mechanisms. If I receive a contribution for documentation for how to do it on other OSs and even non-OpenBGPD and non-SPAMD, I'm very interested and I will post that up on the website as well. So yes, essentially portability is not an issue. The communities attribute is mandated as part of BGP version 4, which I believe was released about, 95, 97?
I think it was even a bit earlier.
Maybe 93, so yeah, so it's been around for a while. And I don't think you should have a problem finding a BGP version 4 available implementation. Any other questions?